Okay, so pretty much this is going to give you the answers to 1, 2, and 3. So I wrote down the values that are on the problem set. So essentially the first thing you're going to do is find the mean for both of the people. So to do that, you add up all of the values and then divide it by the number of values. So for this, it's going to be 171 divided by 9, which gives you 19. And then for this one, it's going to be 279 divided by 9, which is 31. So this is the answer to number 1. McNabb's mean is 19, and then Manning's mean is 31. So now to find the answer to number 2, which is the standard deviation, that's the longer process. So what you're gonna do is subtract the value from the mean. So I wrote it all down. So it's gonna be 19 minus 19 and so on. So it's gonna be 19 minus the value for McNabb's, and then it's gonna be 31 subtracted by the values, since that's the mean for that. So then you're gonna get 0, 1, 3, -12, 3, 2, -6, -2, and 11. So now you're gonna square all of them because you don't want to have any negative values. So just square each one. And then that gives you what you need to get the next, like, get to this process. So 0, 0, 1, 9, 144, 9, 4, 36, 4, and 121. So now this is what you need to put as the sum of the square deviation. So for that, you're gonna add all these values up. It's going to be 328 divided by n minus 1. So 9 values minus 1. So you're gonna do 8, and that gives you 41. So this right here is the variance that you need. And so once you get to this step, what you're gonna do to find the standard deviation is square the variance. So the standard deviation is going to be the square root of 41, which equals 6.4. And this is your answer for number 2 for McNabb's. So that's the value you need for the answer for number 2. So pretty much you're going to do the same process, but for Manning's. So you're going to subtract 0, 0, 9. Oh, JK. Oh, no. Sorry, I already have the square roots. 3, negative. Oh, no, this is -18. 2, 4, 5, -2, and then 4. And then same thing, you're gonna square all of them to get positive values. So 0, 0, 9, 4, 16, 25, 2, 4 squared is 16, and then this is going to be 324. Just double check this, only because I have it written weird. But you're gonna want to subtract the value, or the mean from the value, and then at the end you're gonna square whatever you get. So same thing, to start getting the standard deviation, you're gonna add all these values up, which is 418 divided by 8, because there's 9 values, minus 1, so n minus 1, so 9 minus 1 is 8, and then that's gonna give you 552.3, which is the variance. So the variance for Manning's is going to be 52.3, and then to get the standard deviation, again, you're gonna do the square root of 52.3, which equals 7.23. So this is the standard deviation for Manning's. So this is the answer for number 2. McNabb's is 6.4 as a standard deviation, and then Manning's is 7.3. So that's the math part of it, and essentially the answer to number 3 is whoever has the closest standard deviation to 0. So for number 3, McNabb's has more consistent throws according to his average, because his standard deviation is 6.4, which is lower and closer to the mean, which is 0.